Assalamu alaikum dear students. Students, in this video we are going to explain the part D of our Solow growth model. This part is regarding the steady state and the growth in capital stock. The two forces or variables which we have earlier studied will determine here the steady state level of capital and the capital accumulation. The first force, which is investment per worker, it is abbreviated with small I, and the other force is depreciation per worker, which is abbreviated as delta K. The equation of growth of capital or capital accumulation can be written as del K is equal to I minus delta K. Del K is the change in capital, I is the new investment per worker, and this delta K is the depreciation per workers. One force increasing the capital stock, and this force will reduce the capital stock. When investment per worker is more or greater than depreciation per worker, definitely change in capital will be positive. So there will be increase in our capital stock in our firm. Then the stock of capital definitely will increase, and this is the first scenario when there is investment is greater than delta K. Another scenario is if I is equal to less than delta K, I mean new investment is less than depreciation, then the change in capital is less than 0. So this is why our stock of capital will go down. This is our second scenario. The third one is if I is equal to delta K, I mean new investment, if it is equal to the depreciation, then definitely change in capital will become 0. I mean both forces are equal. So here the stock of capital becomes constant. This third case where investment is equal to depreciation is called steady state when the two forces are equal. We can explain this with the help of a fig. You can observe that the straight line shows the depreciation. Why it has a straight line? We have explained it in our video number 2, and this is the investment per worker line. Investment per worker is a function of capital per worker but with the saving rate. So it is like a production function, but it will lie below the production function. Production function will lie somewhere here. Okay. So these two forces are equal at this point. I mean at this level of K steric, this K steric may be called the steady state level of capital. At this level, our investment per worker is equal to the depreciation per worker. So two important things are here. One is that it is the steady state level because both forces are equal, and the another one is that our K here is stable. I mean if somehow if K increases to this one level, at this level our investment per worker is less than the depreciation per worker. So definitely capital will decrease, and this is the case number 2. So we will move to here at this point. And suppose if we are here at this level of capital per worker, here the force of investment per worker is greater than the depreciation per worker. So definitely investment is coming more, so capital stock will increase. So we will again at this level where investment per worker is equal to the depreciation per worker. So this is the numerical example. If we assume that our K is equal to 9 and saving rate is equal to 0.3 and depreciation rate is equal to 0.1, then y is if we assume that y is a function of K steric, so putting this 9 into here, so we can get y per worker as 3, and investment per worker is this one. So putting this 3 here, and the S we have assumed it is 0.3. So we will get the investment per worker as 0.9. So depreciation is delta, we assume it is 0.1, and capital per worker is 9, and this is again 0.9. So investment and depreciation both are equal here at K steric is equal to 9. Our this 9 is called the steady state level of capital accumulation, where two forces are both equal. Okay, students, this is the end of the simple version of our Solow growth model. In our next videos, we will introduce the changes in this steady state level of capital accumulation with the help of population growth, with the help of saving growth, and with the help of technological changes. Okay, wishing you good luck. Allah Hafiz.